educated people. Well, hello, I am time traveler from future. This is my This is protective hat. Protective hat. Okay, well, looks like you guys can use some calculus. I have looks like my futuristic whiteboard just got transported with me. So now I can teach you about differentiation. Yeah, so you can touch it. Yeah, smooth? Okay, I think we're ready. So if you don't mind and stop touching each other, we can get to calculus. Okay, so lesson number 1. Cusps. See, it looks like a seagull, doesn't it? It's like a bird. Yes, bird.
Bird.
This no diff. There's no. You can't derive this. The derivative doesn't exist here because it's a cusp. See? Okay. Much like a corner. Corner.
Corner.
Yes, corner.
Corner.
Do you say anything other than repeating what I'm saying?
Corner.
That's a no. Okay. We also have. Oh, excuse me, 1 second while I use my magic eraser.
Ooh.
Oh, yeah, that's.
Ooh.
Vertical tangent. The derivative doesn't exist here because there's a vertical tangent at x equals 0. Much like the function, this will be invented in the next 2,000 years. Cube root of x.
Huh?
Yeah, we're not there yet. I probably just ruined this entire lesson for you. Sorry, guys. But. Okay. And now we have discontinuity, which is, in my opinion, the best kind. Okay, so what happens is we have a step function. That will also be invented soon, hopefully. So, you have, say, on the interval from -3 to 1, y is equal to 3. However, on the interval from 1 to infinity, y is equal to -2. Therefore, there's discontinuity at x equals 1. And that is how you calculus to fire.
Friend got firewood.
Friend got firewood. Awesome. We're almost at broken English now. Okay, so this is very expensive. You shouldn't do that. This is a calculator. So, chances are you have no idea what I just said about discontinuity and cusps and corners. Okay, but what you can do is use a handy-dandy calculator. Calculator. Okay, good. Okay, so we learned in the last chapter that you can find the derivative of longhand by subtracting the final minus the initial over the interval. However, now we have a function on our calculator called n-derive, which is located at number 8 in math, that you can use to find the derivative. So you put x in for the terms of the function. You have x to the 4th as your function, and then you define what point you want, say at point 2, x equals 2, and you have derivatives at 32. You can find where a derivative doesn't exist if you take the left hand and right hand derivative at that point, and they are not equal. So, the next order of business is to define the intermediate value theorem. Okay, so what that is that if a and b are any 2 points in an interval on which f is differentiable, then f prime takes on every value between f prime of A and f prime of B. So what that's saying is if f prime of A is equal to 1 and f prime of B is equal to negative 1, then at every point along the line in between, there has to be a slope that is equal to every value in between. So there'll be a point where f prime equals 0, positive 0.5, plus negative 0.5, etc., so forth. Okay. So, did you understand what I just said? Malfunction. Differentiability implies continuity.
Differentiability implies continuity.
I can't tell if it went on one ear or the other, but you said it. So, mission accomplished. Not really sure what's going on. Gave them coffee. And now this. I think on the bright side, they understand calculus now.